So laser, that is valence band and conduction band, and we all know valence band we have what is it? Holes, and conduction band electron, they recombine together to form a laser beam of photon. Okay, and you have to remember another points here. Characteristics of this homojunction semiconductor laser. With it, this question is over. Okay, let me give the characteristics. Characteristics of homojunction. Okay, homojunction semiconductor. The first point I have to write about type of semiconductor. What is this? What type of semiconductor is this? Homojunction. It comes under, or what is the main type I can call this as? Semiconductor laser. Very good. Semiconductor. I can write this as semiconductor. And we can also call this as solid laser. Semiconductor, it is in the form of solid, or you can have this as semiconductor laser. Okay. And the next one is, what is the active media? You have to discuss about active media. So what is the active media here? It is nothing but the, what is this? PN junction. The active media is nothing but PN junction. And what is the pumping method? Third one is you have to discuss about the pumping method. Pumping method is nothing but direct conversion. You have to say this as direct conversion. Direct conversion of light energy into electrical energy. Electrical energy into light energy. Direct conversion. Electrical energy into light energy. And next is nothing but power output. What is the output you are getting here? Power output is nothing but 1 milliwatt. 1 milliwatt. And wavelength emitted. Wavelength of the laser light emitted here is nothing but, it ranges from 8300 angstrom to 8500 angstrom. So these are the points you have to remember under this semiconductor, homojunction semiconductor laser. A first recap of this homojunction semiconductor laser. It is made up of a single element. Both P region and N region are made up of single element. What is the name of the element called as? Gallium arsenide. Very good. And we discussed about the working principle. When it is forward bias, the majority charge carriers move from both the sides. They will come and accumulate near the junction, and there's a chance for them to get recombined with one another. As a result, there is emission of photon, which is known as recombination radiation. Okay, this as we increase due to stimulated emission and due to the increase in the forward bias voltage, this scattered the photons get increase in multiple, and it occurs, the reflection occurs more and more. And at one particular stage, when the laser beam, when the beam is with full strength or with high intensity, it will come out as a laser beam. Okay, and we discussed about energy level diagram, conduction band, valence band, and the gap between them is called as energy gap. And the valence band we have holes, and conduction band we have electrons. As we discussed earlier, they get combined together, recombination occurs, photons emitted. Okay, and coming to this characteristics, I can say what type of semiconductor is this, what is active medium present there, and what is the pumping method, what is the power output and wavelength. So next we have to consider about the heterojunction. So heterojunction, I can give a small hint about this. Heterojunction, you all know that both N and P regions are made up of different elements. Here we have single layers. One P layer, and here one N layer. There we have